Hi and hello to everyone. In this lecture, we are going to discuss on even and odd signals, causal and non-causal signal, deterministic and random signals. We have to understand the classification of signals, then only we can move into the next step of analyzing and processing a signal. Welcome to the lecture. Let us start with the even and odd signal. What is a even signal? If you look at this definition, even signal is the one whose x of t is equal to x of minus t. Here t is the independent variable which indicates the time. So if t is positive, here minus t should be negative. If t is negative, minus t should be positive. What is the meaning? The signal at positive time should be same as the signal at negative time, or the signal at the negative time should be equal to the signal at the positive time. Okay, that is both the signal at the positive time and the negative time should be the same. If you look at this signal, these are the examples for even signal. Okay, observe, this is the positive time, this side it is a negative time. What is the signal present between 0 and 1 is same as the signal present between 0 and minus 1. What is the signal present between 1 and 3? 1 and 3, the signal is minus 2. The signal between minus 1 and minus 3 is also minus 2. Okay, so such signals are called even signal. The signal present at positive time is same as the signal present in the negative time. Okay, right. Another example I can give is your cosine waveform a cos t. Right, we know cos pi by 2 is 0, cos minus pi by 2 is also 0, cos pi is minus 1. Since I am taking the amplitude as a, it is minus a. Cos of minus pi is minus 1, so again it is minus a. So the positive time signal is same as that of the negative time signal. If you take between 0 and pi by 2, same as between 0 and minus pi by 2. Between pi by 2 and 3 pi by 2, same as between minus pi by 2 and minus 3 pi by 2. Such signals are called even signal. For a discrete time case, it is same. Instead of t, we will be using n. And remember, n should be an integer. Integer is nothing but 0, minus 1, minus 2, or 0, 1, 2, 3 up to infinite. Okay, it should be an integer. If you observe the signal closely, let us take an example. At 2, n equal to 2, what is the signal present? 2. At minus 2, the signal present is 2. At 3, what is the signal? It is minus 0.5. At minus 3, it is also minus 0.5. At 7, what is the signal? It is minus 2. At minus 7, the signal present is minus 2. Such signals are called even signal. Okay, the signal at positive time is same as the signal in the negative time. You can compare, right? You can compare 1 and minus 1, they are same. 2 and minus 2, they are same. 3 and minus 3, they are same. 4 and minus 4, they are called even signal. Okay, let me move into the odd signal. An odd signal, the definition is x of t is equal to minus x of minus t. Right, here what is the difference is the positive time and negative time are inverted. Positive time or negative time, or in what is the meaning? The signal at positive time will be, if the signal at the positive time will be the inversion of the signal at the negative time. What is inversion? Inversion means if the signal is positive amplitude, it will be negative amplitude. If the signal is negative amplitude, the signal will be positive amplitude. Okay, look at this example, you can understand. There are some three triangles are going running between the time 0 and 6. Okay, here if you look at the negative time, we have a triangle but it in the negative direction, negative amplitude. Okay, such signals are called odd signal. Let us take some example. Let me say t equal to 1. At t equal to 1, what is the signal present? At t equal to 1, the signal is 2. Okay, then what is x of minus 1? What is x of minus 1? It is here. It is minus 2. What is the condition for odd signal? X of t should be equal to minus x of minus t. Here I am putting t as 1. Sample, some example I am taking, right? So x of 1 is equal to minus x of minus 1. So x of 1 is 2, minus of minus 2 is equal to 2 equal to 2. Right? Simple. The signal which is present in the positive time will be inverted in the negative time. Here it is positive, here it is negative. Suppose this side it is negative, means here it will be positive. Okay, look at this example. You can observe between 0 and 1 there is a positive slope. So between 0 and minus 1 it is a negative slope. Between 1 and 2 the amplitude is 3. Similarly between minus 1 and minus 2 the amplitude is minus 3. Okay, so between 2 and 3 the amplitude is minus 3. Between the time minus 2 and minus 3 the amplitude is plus 3. Yeah, clearly differentiated. Look at the green shades, here positive, here it is negative. Red shades, here it is positive, here it is negative. Here black color shaded, negative, here it is positive. It will be inverted. Okay, positive slope, negative slope, positive square, negative square, negative square, positive square. Look at the time instant, right? You can compare. Okay, between minus 2 and minus 3 here it is positive. So between plus 2 and plus 3 here it is negative. Such signals are called odd signal. This is the definition. X of t is equal to minus x of minus t. For a discrete time case, okay, observe here, at 1 it is 1, at minus 1 it is minus 1, at 2 we could take yes, at 2 it is minus 2, at minus 2 it is plus 2. You can see the relation, it is inverted. At 4 it is 1.5, at minus 4 it is minus 1.5. We can see this sort of signals are called odd signal. Important point to note is for an odd signal x of 0 will be equal to 0. Okay, this is not the only condition. It should odd signal should satisfy this condition. This is very important. This is the condition for odd signal. But if you observe, you can say at t equal to 0, they are always 0. Okay, but this is the essential condition for odd signal. Okay, next, any signal I can split into two parts: even signal and odd signal. Even signal and odd signal. I can say even part and odd part. XE, XO. Again, I have written the definition for a continuous time domain, discrete time domain for even signal, odd signal for discrete continuous time domain and discrete time domain. And as I said earlier, any signal I can split into even part and odd part, even signal plus odd signal. Now in place of t, I am putting minus t. So I know for an even signal, xe of I said this is an even part, xe of minus t is equal to xe of t. So this can be written like this. Similarly, for an odd part, xo of minus t, bring minus to the left side, so it becomes minus xo of t. This minus to left side, minus xo of t. Okay, now if I add this 1 and 2, I will be getting x odd will be cancelled out, so 2xe of t. So bring 2 to the left side denominator, I will be getting this part. Okay, so xe of t is equal to x of t plus x of minus t divided by 2. So if I need an even part of the signal, what should I do? I should take the signal and x of minus t, I have to add those two signal and divide it by 2. I will get the even part of the signal. Okay, now if I subtract 1 and 2, 1 minus 2, by the same procedure if you repeat is 1 minus 2, I will be getting xo of t is equal to x of t minus x of minus t divided by 2. Okay, I request you to work out this relation by yourself. Okay, I have solved for x1 of t. You just try by yourself for xo of t. Okay, this is for the continuous time domain. So the discrete time domain, the same thing, but instead of t, we will be using n. Okay, this is for even signal. This is for odd discrete time signal. Okay. Now let's take an example. For this example, x of t is given. They are asking find the even part and odd part, or even part signal and odd part of the signal. First, let us solve the even part of the signal. For an even part of the signal, okay, right. 1 minute. Okay, fine. Now, what I have done? X of t is given in the question, right? X of t is given in the question. X of t is given in the question. I have to find x of minus t. What is x of minus t? X of minus t is nothing but it's also technically called time folding. Time folding. What is time folding? Time folding is nothing but assume what will happen is Yes. 0, 1, 2, 3, 4, 5. Sorry. -1, -2, -3. Okay, what is going to happen is positive time will come into the negative side. Similarly, negative time will go into the positive time. Okay, this is the relation between x of t and x of minus t. Okay, so if you observe here, what is the signal present between what is the signal present between 0 and 4? This is the signal present between 0 and 4. Okay, now it will come to the negative side. You can observe 0 and 2 has come to 0 and minus 2. 2 and 4 has come to between -2 and -4. Okay, this part. Right? Similarly, between this part, 0 and -2 has come to 0 and +2. This is called time folding. Okay, it is like if you keep a mirror here, if you keep a mirror, two-sided mirror here, if you keep a two-sided mirror here, this side will come this side, negative time will come to the positive side. This is called time folding. Okay, now we have x of t and x of minus t. Now we have to add these two. Adding these two is very easy, just point by point addition. Okay, observe between 0 and 2 we have 2, here 0 and 2 we have 2, so 2 plus 2 4. So between 0 and 2 we will get 4. Between 2 and 4 we have 4 here, between 2 and 4 we have no signal, so we get to have 4 here. Similarly, do for 0 and -2 we have 2, 0 and -2 we have 2, 2 plus 2 4. Okay, between -2 and 4 we have no signal, between -2 and 4 we have 4, so we have 4. So if we are just adding these two, we are adding these two. Okay, so we get this signal. Now, what is the definition? We have to add x of t and x of minus t and divide it by 2. Again, they written the question. This is the same question, right? This both are same. Now I divide by 2. What happens? 4 divided by 2. Now the entire signal has become like this. Okay, instead of amplitude is 4, now it has become 2. This is the even part of the signal. Check whether it is even part. Yes, it is an even part because you can observe the negative side will be same as the positive side, or positive side I can say same as the negative side. Okay, so this is an even signal. X of t is equal to x of minus t. Now let us move into the odd part of the signal. X of t I have taken again, x of minus t. What is x of minus t? I explained already. Again I try to repeat here. This is your positive time will come to the negative time. Negative time will come to the positive time. Okay, so this is your x of minus t. Now what happens? For an odd signal I have x of t minus x of minus t. So I am going to solve for minus x of minus t. So what happened? This signal I am going to multiply with -1. What is the meaning? Positive will become negative, negative will become positive. So this is how I get. So positive has come to negative. Something in negative is there means go to positive. There is nothing in negative, so positive is empty here. Okay, right? Okay, so x of minus t, this is minus x of minus t. Now I can add this x of t minus x of minus t. Okay, I will get this. You can observe here it is 2, here it is -2. So 2 minus 2 it is 0. Here it is 4, here nothing is there, so 4. Okay, so x of t minus x of minus t. Right? So divide everything by 2. So amplitude 4 has become this 2. Such signals are called odd signal. Okay, right? So this is the odd part. This is the odd part of x of t. Right? Okay. Now I request you have found out the xo of t or odd part of the signal. The previous slide I have given even part of the signal. Try to add even part and add odd part. xe of t, xo of t, definitely you will be getting the x of t. Okay, try by yourself. Okay, next we take the discrete time signal. The discrete time signal is given by this signal mathematical expression. The important thing is this arrow. This arrow indicates the time n equal to 0. Left of this indicates n equal to negative. The right side of this indicates n equal to positive. Remember, n is an integer. So this is n equal to 1, n equal to 2, n equal to 3, n equal to minus 1, n is equal to minus 2. I can draw this is in mathematical form, I can draw in the graphical form. So n equal to 0, it is what is the value 1, n equal to 1, what is the value 4, n equal to 2, what is the value 2, n equal to 3, what is the value 1. I have drawn in the graphical form. Okay, for an even part, what I should need? X of n plus x of minus n. X of minus n, what is the meaning? 1 will come to minus 1, minus 1 will come to 1. 2 will go to minus 2, minus 2 will come to plus 2. Okay, they are interchange, right? 3 will go to minus 3, minus 3 will come to plus 3. Okay, here minus 3 nothing is there, so 0. Minus plus 3 it is 1, it goes to minus 3 as 1. Okay, this is the relation between x of n and x of minus n. We are just time folding, changing the positive time, bringing the positive time values to the negative time values to the positive time. Okay, now we have to add point by point addition. X of 0, x of minus 0, we have to add and divide by 2. Similarly, x of 1, x of minus sorry x of 1, x of minus 1 is 1 divided by 2. Okay, let's take some example. Let me take n equal to 1. So xe of 1 is equal to x of 1 plus x of minus 1 divided by, it's like n equal to 1, xe of 1 equal to x of 1 plus x of minus 1 divided by 2. Okay, so which is x of 1 here? X of 1 is 4. This is x of minus n. So this is x of minus 1 is, sorry, here it is minus 3. So it is 4 minus 3 divided by 2. It is 1 by 2 or 0.5. That is what I have given. At 1 it is 0.5. Similarly, try for 2. At 2 it is 2. Here x of minus 2 it is 2. So 2 plus 2, 4. 4 divided by 2, 2. At 3 it is 1. Here there is no signal at 3. So 1 by 1 plus 0 by 2, it is 0.5. Okay. Similarly, fill for each values. Use this expression. You will get this. Observe, it is an even signal. What is an even signal? That signal at positive time will same as the signal at the negative time. You can observe at 2 it is 2, at minus 2 is 2, at 3 it is 0.5, at minus 3 is also 0.5. What about the odd component? Odd component x of n minus x of minus n. This signal you have to subtract from this signal and divide it by 2. You'll get this. Okay, right? You can check it out, right? I will take an example for this case also. Let me again take n equal to 1. X odd of 1 is equal to x of 1 minus x of minus 1 divided by 2. What is x of 1? X of 1 is 4 minus, what is x of minus 1? It is minus 3. Minus minus 3. Seven by 2, 3.5. So we get the answer 3.5. Okay, what is x of 2? X of 2 is 2. Here x of minus 2 is also 2. So 2 minus 2, you have to subtract, right? You have to subtract to find the odd signal. 2 minus 2, you get 0. Okay, check out other values on your own, you'll get this signal. Again, I repeat, this is the even part of signal, the odd part of signal. If you add these two, definitely you'll be getting this signal. Okay, yes. Next we move into the other topic, like causal signals. Causal signal is very simple. Like it's all real-time signals or causal signal. Real-time, day-to-day life, real-time signals. Because we know time is always positive for us, right? Time is always positive, right? You are installing a fan in your room, right? You are installing a fan. The moment you install the fan, that the lifetime of the fan starts, right? That is t equal to 0. It is running for 1 year, means the lifetime of this fan is 1 year. Okay, so the time is always positive. Okay, the signal that does not start before t equal to 0 is called causal signal, right? So less than 0 means it is 0. If you observe this signal, only for positive time it is there, so this is causal. If you observe this discrete time signal, only for positive time it is there, it is also causal. For negative time, there is no signal. All real world signals are causal signals. In real world, we don't have any negative time. Remember, right? Do you say anything negative? Negative time? Do you use anywhere negative time? You will say first hour, second hour. Do you say anyone used -1 hour, -2 hours? No. Okay, right? So real world signals are all causal signal. Next, we move into non-causal signal. Non-causal signal will be there for the negative values of time also. Will start before t equal to 0. If you observe this signal, it is for negative time also. If you observe this signal, -1, -2 also there exists. So these examples for non-causal signal, right? When we have a non-causal signal, once we record the signal and process it. Record the signal and process it. We will have this case. We will have this case. That is our non-causal signal. Okay, what is recording? See, if you are saying you are measuring the temperature of Salem, right? You want to see what is the temperature in the month of July, okay, in 2020. So what we do, we will measure the records of the past few years. Okay, if this is n, if this is 0, this month is 0 for us. What is the last year? That is -1. What is the last before year? That is -2. Once we record and process, there comes the non-causal signal. Okay, then what is anti-causal signal? Anti-causal signal is exact opposite to causal signal. Causal signal is only for positive time. For negative time it is 0, but anti-causal is only for negative time. For positive time it is 0. That is, signal is 0 for all positive time t greater than 0. It is quite opposite. Causal, anti-causal is completely opposite. Okay, right? If you observe, this is only for negative time. For positive time it is not there. Then we have some signals. Is signals called deterministic and random signal. Deterministic signal, go by the definition, a signal whose physical description is known completely, either in mathematical form or graphical form, right? If you can describe the signal either using mathematical equations or waveform, such signals are called deterministic. You can say it perfectly what is a signal type, right? Look at this example. X of t I am taking, it is 1 between the time 0 and 2, 2 between the time 2 and 4, -2 between the time -2 and 0, and 0 elsewhere. For all other values it is 0. Okay, this I can make it in the waveform. This is a mathematical expression. Look at in the graphical form. Between 0 and 2, what is the signal? It is 1. Between 2 and 4, what is the signal? It is 2. Between -2 and 0, -2 and 0, what is the signal? -2. 0 for other values. Okay, such signals are called deterministic signal. Another example I'm taking is t for positive values of time. For negative values of time, it is 0. So t means at time 1 it is 1, at time 2 it is 2. So it is a ramp. So this is the signal. For negative value of time it is 0. Such signals are called deterministic signal. Next we move into random signal. Okay, random signal we cannot predict precisely. Okay, so we will be using probability to say to describe such signal. Such signals are called random signal. Okay, and these signals are there in higher semesters when studying about digital communication. Definitely you will be studying these random signals. In signal system subject, we will not be studying random signals anymore. For that you have to be very strong in probability. That is an entirely different subject, right? In our signal system, we will be dealing only with the deterministic signal. I have given some practice problems for you. Okay, for all the three problems, right? Okay, this is the first problem. Write the mathematical description, find the even part, odd part, and find whether it is causal or not. Okay. Try to represent the mathematical equation. Between 0 and 1, what is it? It is equal to t. 1 and 2, it is 2. 2 and 3, it is 1. between time minus 1 and 0 it is 0, minus 1 and minus 2 it is 0, minus 2 and minus 3 it is 1. Okay, this is your x of t, right? And find the even part and odd part. I will show all the problems. Okay, 3 problems I have listed out, right? This is the problem. Third problem, mathematical, how we can say at t greater than 0 it is 2, t less than 0 it is 0. For the third problem, mathematical equation, this also you can represent mathematical equation, right? I am asking you to write the mathematical form, find the even part, odd part, find whether it is causal or not for all the 3 problems, right? Okay, I hope you learned something from this lecture. Wish you happy learning. Please subscribe the channel. I will come up with some other content in the next class. Thanks for listening. Jai